Here we want to be able to evaluate the integral, and we're going from a lower bound of 0 to an upper bound of pi over 2 of cosine to the 5th power x dx. Okay, so the first thing we want to do is we want to rewrite this in terms of the power of the cosine to the 5th x dx. So we're going to rewrite this integral. So we go from 0 to pi over 2, and we know that the cosine to the power of 5, what we can do is we can rewrite this so that we have the cosine squared x raised to the 2nd power. So that gives you 2 times 2, which is 4, and we still have one more cosine left to factor out. So that would be times the cosine of x dx. Okay, and so now what we can do is now we can replace the cosine squared x with our trig function. So what do we know about the cosine squared x? Well, remember that the cosine squared x plus the sine squared x equals 1. So if we wanted to solve for the cosine squared x, that's going to equal 1 minus the sine squared x. So now we're going to substitute. So we're going to go from 0 to pi over 2, and now we have 1 minus the sine squared x squared times the cosine x dx. Okay, so now we can now decide to then do the u substitution. So we're going to go ahead with the u substitution of this integral. So we're going to go from 0 again, pi over 2, 1 minus the sine squared x squared times the cosine x dx. Okay, so what are we going to let u equal? We're going to let u equal the sine of x and then what do we know about du? Well, du is going to equal the derivative of the sine of x, which is going to be the cosine x dx. And now we can go ahead and then put in our substitution. Okay, so let's go ahead and do that. We have 1 minus u squared times du. Okay, and so the next thing that we want to do is change our upper and lower limits according to what we defined u to be. So we know that u is going to equal the sine of x, which is the sine of pi, and then over here we have, again, u is equal to the sine of x, which is the sine of 0. Okay, so we know that the sine of pi is equal to 1, and the sine of 0 is 0. So let's go ahead and put in our new upper and lower limits. So this is 0, this is 1. And then now we need to expand 1 minus u squared. So remember that this is just multiplying 1 minus u squared times 1 minus u squared. And so we end up getting 1 minus 2u squared plus u to the 4th. So now we end up getting parentheses 1 minus 2u squared plus u to the 4th du. And now we're going to take the antiderivative and then evaluate it according to the upper and lower limits. So the antiderivative of 1 is going to be u. The antiderivative of 2u squared So that's minus 2u. So let's go ahead and do that on the side. So we have minus 2u to the 2 plus 1 over 2 plus 1, which is then equal to negative 2u to the third over 3. So we get negative 2/3 u to the third power. And then what do we know about u to the 4? So u to the 4 plus 1 over 4 plus 1 is u to the 5th over 5. So therefore that becomes plus 1/5 u to the 5th. And we're evaluating it from 0 to 1. So let's go ahead now and plug in our upper and lower limits. So the upper limit is 1, so it's going to be 1 minus 2/3 times 1 cubed plus 1/5 times 1 to the 5th power minus 0 minus 2/3 times 0 cubed plus 1/5 times 0 to the 5th power. Okay, so now we want to be able to then solve here. So anything times 1 is going to be itself. So we want to be able to find a common denominator. So it looks like that 15 is the common denominator. So we have 1, which is 15 over 15 minus denominator is 15, 3 times 5. So it's going to be 10 over 15 plus over here this is 15 and that's 3. And then that's going to be minus, well, this entire thing is going to be 0. So 15 minus 10 is 5. 5 minus 3, or excuse me, 5 plus 3 is 8 over 15. And therefore there is our result.